these are things that like I think people that work in this language for a couple months like just know, unfortunately.
So you mean they're included just for academic reasons?
That would be my guess.
Makes sense.
That would be my guess.
There's a slightly more subtle thing than that though too though. I mean, yes, head you might not use when you mean something else. Like I want to behave in this way when there's an empty list.
Mm-hmm.
But there is no general solution to that. So safe head works for somebody who needs to know that piece of information in some particular way. But it's not a general solution to that problem because what you want to do is actually respond to the fact that it's empty. So if you know that your contract it's always going to be run against something that has content, then head is perfectly fine and may mean exactly what you mean. You want to blow up when there is nothing in the list, right? That's a meaningful expression. As we talked about, the proliferation of maybes and things like that throughout your code, as opposed to just crashing when something isn't working right. If you know that the contract is don't hand me anything that's empty, it's perfectly fine to blow up on somebody who hands you something empty.
Well, depending on what you mean by contract, if what you mean by contract is the type, then I respectfully disagree with that, because as this example demonstrates, the type itself is if you give me a linked list of A, I will give you an A, and that's actually not that is not always possible, right?
Well, no, I can give you a bottom, for instance, which is
that will type check, but it will blow up at runtime, like because bottom is an inhabitant of all of these types.
I'm saying it's not. What I'm saying is that blowing up or returning bottom is a perfectly tight. It's a sound implementation of this because it does return an A.
Mm-hmm.
Just so happens I can't interpret that anywhere else except out of that.
Yeah,
So,
I mean,
I think I'm just saying. All my point was that it's more nuanced than just saying never do this and never. There isn't a good case for saying never do anything.
Well, I personally say never use head,
right.
And some other people say that it's more nuanced than that. But I mean, it would be possible to write a function that takes a string and returns a string. And in the implementation of that function, I say that if your string equals foo, that you should throw a synchronous exception, right? But the contract that I've exposed, that is to say the type, does not communicate that that function is actually partial over the stated domain, in the type. Given that types are really the best way, in my opinion, to communicate like functionality in this programming language, like I try to write functions that are fully defined over their stated range or domain. Yeah.
No, I think there's also one more purpose to it, right? So don't use head because your fold or map will actually take care of this already. So in the sense that you use a better paradigm than trying to use head. So I mean that's really kind of what this thing is.
Yeah.
The only cases where I actually ever used head or tail or one of those functions is if I pattern match. I guess like you're saying, like you pattern matched previously in the inputs, and I know those things already exist, but I still want the whole list to break apart later on.
And I think that's kind of what you're saying. Like if in the prior piece of code, like you have written something that will prevent head expression from being evaluated if you don't actually have like a list of length 1 or greater, then like it could be perfectly valid to use that.
This might be the most clear way to express something rather than packing it into a safe head and then unpacking it down the road, from that safe head's return.
Yeah. And to be fair to Greg, like you see in the implementation of functions, incomplete pattern matches and use of partial functions every once in a while in some pretty serious libraries. But like those, the inputs of those functions have been essentially like guarded against these pathological cases like prior in the code base. So I don't do it because I'm too dumb to remember to like always like ensure that my list is going to be non-empty. For instance, I find it just easier to use these functions that will force me to do the pattern matching to ensure that my larger function is fully defined. But yeah, I suppose there's no one way to eat the Reese's. But this person right here is a professional like Haskell programmer, Brett Yorgi, who says head is a mistake. So maybe what they're trying to communicate is that head being included in the prelude and available for you to use without you asking for it is a mistake.
I guess you misspelled this guy's name in the course. It's Brett instead of Brett.
Did I say Brett?
Yeah, double T. It's actually NT.
Oh, that was dumb of me.
I couldn't find this guy. Like,
Who is this
guy? Who is Brett?
Who is this person?
And then Brent Yorgi's shape showed up.
Well, what did I say? Brett? Oh man, Brent Yorgi. How embarrassing.
Yeah,
Watch.
interesting. This kind of like
Using the power of computers. I'll change it there, anyways. Okay.
yeah, that's the guy. Cool. Thanks.
Okay. Yeah. Sure.
That was awesome. Yeah.
Anything else in there? I personally don't think that we've gotten to like the weird Haskell stuff yet.
Yeah.
I think next week the weirdness begins. But I'm sure, like, show of hands, like, who has used some recursion pattern in the last month of their day job at this company? A lot of us, right?
Day
Like
job.
fold and map and stuff like that, like, are probably implemented using some recursion, like, under the hood. So this shouldn't be a huge surprise.
I guess somebody's trying to talk to you. That thing bounced.
It bounced. Let's see. What is it doing? Oh, somebody is trying to. Oh, Bill digitally raised his hand. Thanks, Bill. I was like, what is that message? Cool. Okay, cool. Well, without further ado, I'm going to switch over to. Oh, Mark's not here. And the other person who was going to volunteer to show the code is not here either. One of you folks on the phone, you guys always manage to weasel out of having to show your homework assignments by virtue of not sitting in the room and making uncomfortable eye contact with me. Can I convince one of you to share your screen and show your golf solution? Nice. All right, I'm going to switch presenter to you, Bill. I promise it doesn't contain malware. This is, yeah, we're looking at the assignment for week three assignment. Yep, yeah, we have it up on the. Yep, we see your screen now for KDE terminal. I don't know. Oh yes. So what Skip needed to do? I forget what Skip needed to do. Sure. You're a maverick. You're already on week 5. It does. Okay. Okay, so first pass over the string, you skip 0. Second pass, you skip every 1 elements. Third pass, you skip every 2 elements until you hit the length of the string. Okay, I got you. Sure. do. Uh-huh. Okay. Okay, so it looks like you create tuples, like for each element in your original list. I see you're mapping do skip XSS, which is okay. So and then do skip like creates a tuple for each item in the original list and an index, which is like you're creating an infinite list with the one dot dot. Is that what that is? Are those of you in the room familiar with syntax? Have you ever seen this before? Okay. For those of you who haven't, it's you're creating an infinite list starting at one. There are other things that you can put in there, like some information about like how to create the next item in the list, for instance. But this is just creating an infinite list from one, two, three, four, five, etc., etc. Okay. Hmm. Sure.
So actually, this is the common observation. Even I felt like that. I don't know, if just the way the code is, the way Haskell code is written, just the way kind of, I felt the same way. I think about it.
Yeah. Sure. 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 Yeah, I mean, I think to address a point that was made in the room about the write only nature of some of these homework solutions, I think that like it should be noted that we're doing these toy problems uh, to sort of drive like an understanding of pattern matching and recursion, like tree recursion, different recursion patterns, and in this lesson, parametric polymorphism. Um, I think that there's nothing necessarily about these assignments that like warrant particularly complex solutions, the but I think like the actual Haskell code that you may see that like puts a foo in the database and loads a user out of a database doesn't look like this. Um, you know what I mean? I mean, look at the type of this skips function. Like you have a list, you have a polymorphic function that operates over a list of some type and gives you back a list of some type. Like, do you find yourself doing that like at work ever? Probably not. So it doesn't surprise me that like looking at the solution to an assignment where you're asked to implement a function of this type, the solution actually looks unfamiliar to, or it looks dissimilar to what you find yourself doing in your day to day. Yeah, what's up?
Well, I was just gonna suggest that if one took the time and tried to simplify this and make it more readable, there's probably a ton of room to make this particular more readable. Probably
Yeah.
not thinking about that when you're doing the homework, trying to figure out how the language works.
Sure.
But one goal of this homework was actually to make it as short as possible.
Oh, is it? Okay.
Number of characters.
Oh, see, I'm totally out of the loop. Yeah. Right.
This is a code golf exercise. You're supposed to actually try to. You're doing that on purpose.
I think the intent was to use as many library functions as possible instead of.
Was it, is that like an exercise the obfuscated code contest.
Not
I
obfuscated.
know Vim Golf, yes, of course, you want to do this, like, walk letters, right? All of that. But this particular, like, use as any, like, library function that also does rolling your own recursive stuff. So I guess that's the intent, instead of make it, like, unreadable, because Haskell's already up here. I was saying, so, like, talking to, like, figure out that it's already hard to read other code in other languages, but Haskell makes reading our own code hard. Like,
Do you speak German?
No.
Really hard.
I've heard about. I always feel like rules, so I'm like, okay, I get up here.
Yeah, I mean, yeah. So I think I don't know the professor personally, but if I had to guess as to what their motivations were in creating this assignment, one, they're trying to teach a concept. They're trying to teach parametric polymorphism, and they could have just They could have just asked you to implement like map in terms of fold and filter in terms of fold and all the crap that you would see in like functional programming in Scala, the Yarn book or whatever. But adding the code golf aspect to it, and also pushing you to go into the documentation for the standard library, makes it a little just different than like the that other type of like learned parametric polymorphism. So I don't think that that the author of this assignment is advocating that like you should code golf any of your real Haskell code. They're just trying to make it interesting for undergraduate students, right? This is a course that 18-year-olds take when they first get to university that don't know anything about like probably don't know a lot about like writing code that others can read. They probably never used version control before, or like, but they're trying to keep it interesting for them. Okay, let's keep cruising. Let's look at local maxima. Yep. Yep. Mm-hmm. Nice. Did That's awesome. Did anybody in this room come up with a solution to local maxima that did not leverage pattern matching in that form that we're seeing here? No. Just curious. I've seen this solved like, oh yeah,
You did it a little bit different, but it's the same concept.
yeah. Do you mind if I pull it up?
Sure.
Bill, I'm gonna hijack your screen for a second here, if that's all right. Sure.
Looking at Bill's solution, I think mine might have been wrong because I was also dropping the B in the else case.
Oh, okay.
Yeah.
All right. Well, let's check it out. Let's see what we got. Wait, what is your GitHub username? Oh.
Oh,
Bill, I'm muting you because you appear to be in a wind tunnel right now. All right. Okay. So, is this the solution? This is local maximum. Is this you?
Yeah.
Nice. Okay.
I was just using an if statement instead of the matching that he was doing.
Okay, cool. So you didn't use a guard. You did some pattern matching, but no guard. So help me understand. Help me understand what you did.
Okay. So the basic case is line 23, where we're just comparing B to A and C.
Mm-hmm.
We're going to add it to the beginning of the list.
Yep. Okay.
Recurse using a local maximum.
Nice.
Otherwise, actually I did add the B. Okay, yeah. Yeah, we actually wasn't passing the test, and I remember why.
Gotcha.
Yeah, so I go ahead and recurse in the else case also.
Gotcha.
21 is a special case I made just for, I wasn't sure why it wasn't working right, so I added a special case just if the list was only three items long. Probably not necessary.
Okay. Yeah, if I'm looking at this, I'm thinking that this would cover this, but I have not squinted my eyes probably in the right way. Cool, I got you. So yeah, so you use pattern matching, you use guards. Um, yeah, looks good. Right on. Okay. Does anybody else in this room mind if I pull up their solution to the
so
histogram?
I did another solution with this where I was trying to not use recursion but the same pattern matching. There is local maxima 2 in my case. So one is exactly like that, but 2 is where I'm
Nice.
using a group 3. So group 3 is almost equivalent to, so basically I'm kind of just going through the list and grouping 3 items.
Okay.
And I'm using the same implementation as skips for this, except for the filter part of it, does something different.
Okay. All right. So let me start at the top. So local maxima 2, it maps over the result of this expression. Is that correct?
Yes.
Okay. And then so what goes into filter, the list that goes into filter is the result of this expression. Okay. And so this expression is okay. So let's see, a composition of map and unzip and filter. Okay. So explain to me.
Right. So so this guy. Okay, as I said, let me just read this again.
Sure.
The basic premise for this was if you have a list, it will take first, second, third element, second, third, fourth element, third, fourth, fifth element. Basically, it's creating those groups.
Okay.
In the next part, basically the local maxima, I'm just making the check that I need to make, and then plucking out the second field, the second value out of each of the matching criteria. Now, how I'm doing it is okay. I know it works.
I know it works, but how does it work?
Yeah,
No one will know.
So,
That's a smell.
position.
Somewhere that means it's almost like in my nose. Because this is a good smell. This is cooling down.
Position minus
Try
1.
something. Might not be your nose. What does it want to say if something equals true? You say it's something, right?
It's fine. You don't need to riddle
Yeah,
it. You don't need to riddle it right now. But it's interesting to see that there are obviously there are multiple solutions to the same.
So the group 3's implementation is pretty similar to my skips implementation, except that I changed the filter. I was kind of thinking there is a pattern to all these functions, and once you implement skips,
You can
pull
use
something
them.
common out of it
Totally.
and just provide the criteria in there. But then I kind of implemented the other one version of it, which was much more simpler, I thought, and I gave up at that point. So.
Gotcha. Cool. I was going to ask, for those of you that are writing Scala on the day-to-day, did this signature seem familiar? I haven't done enough Scala. No, you guys are not using. I know type variables do appear in higher order functions in the Scala standard library, right? Like I believe that things like option come in the Scala standard library, right?
You mean they're parameterized in here?
They are parameterized, and the type of the argument is not known to the callee. I see this stuff sometimes. You can't really read it.
Yeah, it gets kind of esoteric.
It's not something that you find yourself doing much in the day-to-day. Like maybe consuming methods with that type of parametric polymorphism, but maybe not writing them much yourself.
It just takes me a long time to decipher all that Scala stuff. It takes me a long time.
Yeah.
To stare at it.
Yeah.
It doesn't sink in.
Well, I've read a fair number of highly type parameterized functions in Scala. It's just whenever you see the pattern and you want to extract it out, then,
Gotcha.
but I mean, is that what you're looking for?
Yeah, I was just curious, like if a type variable, if this was the first time folks had seen type variables.
No, you wouldn't see that. I wouldn't see that.
Okay,
They're all over
great,
the place.
cool.
Well, I mean, my Java code looks like that.
Yeah, sure, right. Java generic's been around for a long time. Cool, right on. Okay, do we have a final volunteer to show their histograms? Oh yeah.
Histogram? Okay,
Well,
sure.
let's
Sure,
look
go
at
ahead.
both. Mark W. The histogram. All right, Mark, what did you do? What is this histogram? What's it doing?
Well, it's doing a lot. So, line 25,
Uh-huh.
Nice.
you're converting a bunch of rows, which are the strings, which are the asterisks.
Mm-hmm.
You're unlining them and you're concatenating them with the template, which is just the bottom part. So, but on the first line, I've got XS as a parameter. I don't even use it on the first line.
You use it down here.
Yeah, it gets used way down there. So the key idea was to compute the frequencies of each number in the array. And that the group sort thing gives you that, right? But it gives you an array of arrays.
Right.
By the way, Clojure gives you a built-in function to do that frequency thing. Yeah. Yeah.
You just wrote it.
Yeah, huh? Yeah, I know, but I had to go, like, I couldn't just use it. So, having done the group sort
Another
thing,
problem.
right, then I map it and say, okay, I'm going to take the head of each, which is the number, and then how many there are. And so that gives me a list of pairs, where the first is the number, 0 through 9, and then the second element of the pair is how many times it occurred.
Okay, so cat would be like you'd have C1, A1, T1.
Yeah, except in this case we have numbers, right? So, but yeah, it's the same idea, right? The beautiful thing is that array of pairs can be used as a map. So I needed down below, having computed the frequencies, I needed who appears the most.
Determine the line height. Oh.
Yeah, so how many rows do I need to draw? So that's the max frequency thing on the bottom. I take the max. That ++0 thing is just a one-off in case you're trying to do a histogram of an empty array and it's blowing up. So I just put the ++0 to prevent max from failing.
Okay.
In that one-off case. So you got the frequencies and you know who, or at least how many rows you need to render. Okay. So then, going back up to line 26, I say, all right, well, how do I create each row? And so you need to draw the one with the most frequencies first.
Because you go like
you go from top
to bottom.
So I take reverse 1 to max frequency, and that gives me those numbers in reverse order. I use zip with the function histline, which is draw me one line on the histogram.
Histline here.
Histline draws one line.
Okay, I gotcha. Okay, so you go from 0 to 9, and if
From
you're
left to right.
From left to right, and if you're looking at your frequencies list.
Right. So the first row is the row with the most frequencies. And so you go. So on line 27, you go from 0 to 9.
Yep.
And you look it up in the frequencies.
And draw a dot if you find it. And
if you find it, and if it's there, and if the number of frequencies exceeds the row, then put an asterisk. Otherwise, put a space.
Yeah.
Nice. Cool.
Just row, so it returns a maybe.
Just row lookup returns a maybe.
Yeah, of course.
If it's not there, it returns nothing. In which case, the greater than or equal to returns false.
What is the type of lookup? What is that, or even asked differently, like what does that function do?
Signature.
It looks up a number in a map and returns either value or nothing.
You mean list?
Yeah.
So going back to your cat example, right? So
There's a bunch of
you would look up cat.
could be tuples, man.
You look up C in the map, and
Mhm.
if C is there, you say, oh, C is there. What's the number of occurrences? 1, 2, 3, whatever.
Okay. I was just trying to figure out when you were saying map if you meant like a
Like a hash map. in
yeah.
Java.
Okay. Cool.
Not a function map. It's a hash map.
Gotcha.
Sorry, I guess I mixed it
So
up.
what's the key? I mean, I didn't get it.
The key is the number 0 through 9.
Mm-hmm.
The value is the number of times it occurs.
Cool. Sweet. I got you. So you just go from
Yep.
top to bottom.
Just from top to bottom.
Awesome. Cool. Thanks, man.
That's it.
Joe, do you mind if I show yours?
Go
You'd
ahead.
be embarrassed.
No.
No, Joe fears nothing.
Would you not show it if you did say you would be embarrassed?
That's an excellent question.
Let's show mine.
Oh, there we go.
Well, presumably you're showing it because you like it, not like this is a bad example.
No, he used
Very similar.
he did it. Yeah, he did it in a similar way, but he used transpose and concat map, which was novel and cool. Did you also, Joe, construct the list of characters essentially from top to bottom? I saw these words in here, and I haven't scrutinized the solution, but I think you might have done it a little differently than, like when I say like highest frequency to lowest frequency, constructing a string. Did you do it in the same fashion that Mark did, where like he went from highest frequency to lowest frequency?
Yeah, maybe.
What does transpose do?
It transposes the list of lists. So that's what I'm actually printing out, the columns. So instead of being like rows, like going up and down, I just flip it.
That's what I was thinking.
Okay.
So what?
So actually, that changes the solution. Yeah, that's pretty.
So would you be willing to draw what transpose does, like on that whiteboard, so we can look like maybe?
Initially, I had
Wait, I'll show you.
Initially, I had the.
That's what it does.
Initially, I
takes all
had
the columns.
the replicate on the flip on the other side. But
Okay.
that was the wrong way because they transpose it from one origin to the other, but I didn't really look, so I just switched it.
Okay, let's.
So I'd imagine it does something close to.
Doesn't it just swap columns for us? That would be.
And maybe the first inputs. Let's see.
Mm-hmm.
Yeah, I have to think about this. But I would imagine it would take. So this would be a list right now. And then what's the list?
Mm-hmm.
Let's see.
So the example I'm seeing online is like you've got a list of lists, and the first sublist contains 1, 2, 3, and the second sublist contains 4, 5, 6, and then you end up with
Oh, you mean
1,
like
4,
that,
2,
yeah,
5,
yeah.
3, 6.
Yeah,
Okay.
It takes the first out of
So you want
everyone
the-
and turns that into.
I got you.
Yeah, okay.
I know. I'm trying to remember how to do this. That's like
That's-
without
that's
like
why it's a-
JCI open. You're
So
like,
my
Yeah,
initial
3
solution,
by
I
2.
didn't use transpose. I just
Alright.
had like a lookup table, and
2
I
by
just
3.
clicked on it.
Oh, I got
Because I
you.
didn't
That's
know
all
what
mathematical
transpose
transpose
stuff. Because I didn't want to
Gotcha.
write transpose
Yeah.
Cool.
on the board.
Yeah, so rows become columns, columns
Yeah.
become rows. Yeah, that's smart.
Cool. So then you can just build the thing out and just flip it in
Yeah,
one.
yeah.
Yeah.
That might be like easier. When
Yeah.
you build stuff and then it's like one line, and then when you actually draw it.
To the point of our earlier conversation about like the instruction to use as many functions from the standard library as possible, I think like the discovery process, that ultimately results in you like finding that transpose exists. Like you won't forget it. Now you know it exists. You know how to find things in the standard library, et cetera, et cetera. I think this homework assignment was trying to like push you down that path a little bit. I didn't know the transpose existed either, and my solution is like a bajillion characters long because I did all sorts of crazy flipping and so on and so forth.
So you build it out to the right and then flip it this way.
Yeah.
Pretty awesome.
Sweet.
So sensible, right? Cool. Okay, so it's 12:49. we all have stuff to do. Let me look. Is there anything left to talk about? So Adrian's going to facilitate the meeting next week while I'm not here. Sean's going to present on type classes, and we are going to review. If we have time, we'll review the week 4 homework solutions. But I think it would be better if from here on out we focused more on just a discussion of the lecture. And then if people come with some questions about the homework that they are about to do, we can chat about it as a group. You, Adrian, also wanted to set up a Tuesday at noon Haskell study group.
Right, yeah, I'm going to send out a meeting invite to everyone. I just don't know who to include in all that in that email list that I'm going to be sending that out to. So is there like a
I haven't set up a distribution list.
Okay.
You could just, I will copy and paste to you all the people that are in this invite, and then for those of you that receive that message, you could just like.
I mean, if they're not interested, they just won't show up, right?
How do I send it to the whole floor?
It's like a CJ.
Messaging, I think.
Whole floor at CJ.com.
Whole floor at CJ.com.
Actually, yeah, I'll just do that. I'll just send it to the whole floor. And then
Okay. Yeah, right on.
And I was thinking of it being more of like an office hours type of thing, where like everyone could just sit down and do the homework together, just an hour, just everyone just do homework in the same room. So if someone gets stuck or has ideas, we can bounce.
Cool. Yeah, and I'd love to feel important, so I'll hang out there and answer any questions that you may have. And then that discussion can be brought up again with the larger group on Thursdays.
Sure. I also do not want to exclude anyone that's not in the Westlake Village office, so maybe we can do some sort of like video conference thing like this.
Yeah, we'll just do the same. Yeah, we'll do the same thing. And speaking of that, for those of you on the phone and those of you here, I'll take the video and audio from this meeting. I'll YouTube it. I'll stick it on the tubes, and I'll send you all the link in the Haskell chat. Sound good? Okay. Adjourned. Meeting adjourned.
Yay. So did you mean that the meetings going forward would discuss the current upcoming assignment or the assignment that we are, not the assignment, but the material?
Yeah, I'd like to focus, so next week Sean is going to be talking about the lecture material that will be drawn upon to do the next week. And I'd prefer to focus on that.
No, I didn't understand what you meant.
Mm-hmm.
Oh.
What?
I was hoping that you would say
I'm
that.
sorry. Maybe one of my chickpeas.
Not a chickpea. I've got about.
I like them, but there's so many. They put like 3 tomatoes in it, and then just like all of the chickpeas.
Whether cheap.
How do I stop?